Question 1. To better understand the interaction between sensible and latent heat loads in an air conditioning system, a contractor examines the psychrometric behavior of a space being conditioned. The return air reads 78 deg for dry bulb and 65 deg for wet bulb, while the supply air measures 55 deg for dry bulb. Assuming airflow remains constant at 1200 CFM, which of the following is the most accurate conclusion about the latent heat performance? A. The latent heat removal is negligible due to the low airflow rate. B. The system is performing suboptimally because sensible heat removal exceeds latent. C. The latent heat removal is effective as shown by the drop in wet bulb temperature. D. The wet bulb depression indicates insufficient dehumidification performance. Answer. Correct answer. C. Explanation. The drop in wet bulb temperature from 65 deg to below 55 deg indicates both sensible and latent heat removal. Wet bulb is function of enthalpy and moisture content. Since the system achieves significant reduction in wet bulb, latent heat, moisture has been removed effectively. This is supported by ASHRAE Fundamentals Handbook and RSES Psychrometric Instruction Guides. Question 2. Under the assumption that a technician encounters a start capacitor failure in a SE mower system, which fails to initiate the compressor on a hot summer day, which of the following is the most technically appropriate diagnostic conclusion? A. The capacitor is shorted, resulting in continuous compressor operation. B. The relay is open, causing the run winding to overheat. C. The capacitor is open, preventing start winding engagement. D. The motor's common terminal is grounded, bypassing the start circuit. Answer. Correct answer. C. Explanation. An open start capacitor means the compressor cannot overcome error lock rotor amperage due to no current flow in the start winding. This is a common capacitor failure. RSES electrical component diagnostics and NEMA motor guidelines emphasize testing capacitors with multimeters for continuity and ESA equivalent series resistance as part of standard diagnostics. Question 3. As demonstrated by a supermarket application, Mr. Timmons notices that multiple display case coils are frosting unevenly and product temperatures are gradually rising during the defrost cycle. The system uses multiple evaporators in parallel with an EPA valve and electric defrost. What is the most plausible underlying cause? A. Defrost termination temperature is set too low. B. EPA valve is stuck open, overfeeding downstream coils. C. Suction header is partially restricted, starving upstream coils. D. TSV bulb placement is too close to the evaporator inlet. Answer. Correct answer. C. Explanation. Uneven frosting and rising case temperatures during defrost strongly suggest a suction line restriction upstream, which would limit refrigerant vapor return and reduce boiling within the evaporators. RSES troubleshooting standards stress the importance of equal refrigerant distribution and proper piping design to prevent such maldistribution in multi-coil setups. Question 4. Given the circumstances of a rooftop unit cycling on and off rapidly with no call for cooling from the thermostat, technician Is Rivera observes a short cycling condition and suspects control malfunction. Which of the following control faults is most likely to cause this issue? A. Defrost timer is set to manual override. B. High pressure switch is defective and intermittently opens. C. Low ambient control is stuck in cooling mode. D. Shorted thermostat wires are simulating a false call. Answer. Correct answer. D. Explanation. Shorted thermostat wires often R to Y create a continuous signal to start cooling regardless of actual demand. This results in rapid cycling and possible compressor damage. Per RSES and NEC standards, thermostat wiring should be checked for continuity and resistance and properly isolated from conduit grounding. Question 5. The evolution of vapor compression systems introduced the use of subcooling and superheat as diagnostic tool. If a technician records a low suction pressure, high superheat, and low subcooling, which of the following conclusions is most consistent with the refrigeration cycle behavior? A. The system is overcharged, flooding the condenser. B. The metering device is overfeeding the evaporator. C. The evaporator is starved due to undercharge or restriction. D. The compressor valves are leaking, causing high discharge pressure. Answer. Correct answer. C. Explanation. Low suction, high superheat, and low subcooling all indicate insufficient refrigerant flow reaching the evaporator. This may be caused by a low charge or a restriction at the metering device or filtered via. RSES training aligns with this diagnostic pattern and recommends stepwise evaluation starting at the liquid line. Question 6. When considering system evacuation, technician Mr. Malik pulls a vacuum on a newly installed system using a single-stage pump and digital micron gauge. The reading stabilizes at 1200 microns after 1 hour. What is the correct course of action based on standard protocols? A. Proceed to charge. At 1200 microns is an acceptable final level. B. Break the vacuum with nitrogen and pull again to below 500 microns. C. Open the system and replace the oil in the vacuum pump. D. Charge with refrigerant to force remaining moisture into the condenser. Answer. Correct answer. B. Explanation. A final vacuum level of 1200 microns indicates remaining moisture or system leaks. Per RSES best practices and the EPA Clean Air Act Section 608 standards, a system should reach and hold 500 microns before charging. A standing pressure test using nitrogen is recommended before retrying evacuation. Question 7. Based on the information gathered from a facility audit is Daniels observes airflow imbalance across multiple valve boxes in a commercial HVAC system. Duct static pressure is high, but some zones still lack sufficient airflow. What is the most technically sound explanation? A. Return ducts are oversized, creating a backdraft. B. The supply fan belt is slipping, reducing blower RPM. C. Improper valve damper calibration is restricting airflow. D. Outdoor air damper is stuck open, overpressurizing the plenum. Answer. Correct answer. C. Explanation. High static pressure yet low airflow in certain zones usually results from poorly calibrated or failed valve box dampers. This causes uneven zone delivery despite adequate fan output. RSES air distribution guidelines and SMACNA duct design standards emphasize zone balancing for efficient operation. Question 8. In light of recent developments in electronic expansion valve EVE technology, technician Mr. Singh compares performance of EVES and ESVS. He notes that the EVE maintains tighter control at varying loads. Why is this characteristic advantageous in modern systems? A. EVES do not require a sensing bulb, reducing installation time. B. EVES can operate without power, improving reliability. C. EVES use feedback algorithms for real-time superheat control. D. EVES inherently increase subcooling across the condenser. Answer. Correct answer. C. Explanation. EVES utilize microprocessors and sensors to monitor pressure and temperature, adjusting valve position to maintain precise superheat, which improves efficiency under dynamic load conditions. RSES standards recognize EVES for better load matching and faster response compared to traditional thermostatic valves. Question 9. To illustrate this point, Mr. Chen is diagnosing a sealed refrigeration system located at high altitude. He finds that the head pressure is significantly lower than normal sea level readings. How does this observation relate to the gas laws affecting refrigerant behavior? A. Lower ambient pressure decreases compressor volumetric efficiency. B. Boyle's law explains the refrigerant's expansion under low pressure. C. Charles's law causes rise in suction pressure at altitude. D. Dalton's law clarifies reduced condensing pressure from thinner air. Answer. Correct answer. D. Explanation. At higher altitudes, atmospheric pressure decreases, reducing the condenser's ability to reject heat. According to Dalton's law, the partial pressure of air molecules is lower, which limits heat transfer, reducing head pressure. RSES refrigeration principles and ASHRAE handbooks discuss altitude impact on system performance. Question 10. From a practical standpoint, technician Evans is tasked with servicing a rooftop condenser. When lightning is observed nearby, her supervisor instructs her to finish quickly. What is the correct safety-based decision according to industry standards? A. Continue working but avoid contact with electrical components. B. Immediately cease work and evacuate to a safe indoor area. C. Finish the current step and then exit the roof. D. Disconnect power and remain on the roof until the storm passes. Answer. Correct answer. B. Explanation. OSHA 1910 standards and RSES safety protocols mandate that all outdoor work cease immediately during lightning storms. Rooftop units pose increased electrocution and fall risk. Worker safety must always override productivity concerns in storm conditions. Question 11. From multiple perspectives, technician Mr. Lorenzo needs to retrofit a commercial R22 system with a new HFC lens. After replacing the expansion valve and filter dryer, he charges the system with R438 but notices oil return issues. What is the most probable explanation? A. Oil is incompatible with R438, reducing miscibility. B. The compressor crankcase heater was left energized during charging. C. The system still contains residual mineral oil impeding oil circulation. D. The condenser fan cycling is preventing proper head pressure control. Answer. Correct answer. C. Explanation. R438 is designed to work with existing mineral oil to an extent, but residual oil may still cause poor return depending on pipe configuration and load conditions. RSES retrofit guidelines recommend flushing and replacing oil with PO for reliable miscibility and oil return in retrofits. Question 12. Upon closer examination, a technician reviews a heat pump that stays in heating mode despite thermostat calls for cooling. The reversing valve is receiving 24th as expected. What is the most likely root cause? A. The outdoor ambient sensor is stuck in defrost mode. B. The reversing valve is mechanically stuck in the heating position. C. The defrost control board is energizing both Y and O terminals. D. The thermostat is configured for a heat-only system. Answer. Correct answer. B. Explanation. If 24th is applied to the reversing valve but no change occurs, the valve is likely stuck or its solenoid coil is failing under load. This results in a system locked in heating mode. RSES training recommends both electrical and mechanical verification of valve movement and solenoid operation. Question 13. The relationship between indoor relative humidity and coil surface temperature plays a critical role in dehumidification. If a system is oversized, which of the following outcomes is most probable in a high humidity climate? A. System will short cycle and fail to adequately remove moisture. B. Subcooling will increase due to the lower ambient load. C. The evaporator will ice over more frequently. D. Indoor air will become too dry, causing comfort issues. Answer. Correct answer. A. Explanation. Oversized systems cool air too quickly, resulting in shorter run times and insufficient latent heat removal. This leads to high indoor humidity and comfort complaints. ASHRAE and RSES emphasize correct sizing using manual J and D for balanced, sensible latent control in humid regions. Question 14. In response to repeated compressor trips on thermal overload, technician ISNOVA verifies amp draw and voltage are within specifications. However, the system still shuts down intermittently. What is the most likely root cause? A. Faulty internal overload in the compressor motor winding. B. Excessive refrigerant charge causing high head pressure. C. Undersized suction line preventing oil return. D. Restriction of the condenser inlet raising subcooling. Answer. Correct answer. A. Explanation. If amp draw is normal and voltage is stable, an internal overload may be failing prematurely due to heat soak or age. Internal thermal switches can degrade over time, leading to nuisance trips. RSES troubleshooting protocols suggest testing winding continuity after cool down to confirm. Question 15. Examining the consequences of miswired fan relays, technician Mr. Patel notices that the electric heater elements remain energized even when the system is in cooling mode. Which of the following is the most likely cause? A. Reversing valve is not energizing in cooling. B. Sequencer is wired ahead of the blower contactor. C. Auxiliary heat is miswired to the Y terminal. D. High pressure cutout is shorted to the G terminal. Answer. Correct answer. C. Explanation. If auxiliary heat is energized by a cooling coil Y terminal, it suggests a miswire between the heat relay and cooling demand circuit. RSES electrical wiring diagrams caution against improper terminal routing in heat pump controls to prevent simultaneous heating and cooling. Question 16. Contrary to popular belief, reducing condenser fan speed in a water-cooled system doesn't always improve efficiency. In which condition would a low fan speed actually increase energy consumption? A. During low ambient conditions with reduced heat rejection. B. When cooling towers experience scale buildup on fill media. C. When compressor discharge gas is overly superheated. D. Under full load with low entering condenser water temperature. Answer. Correct answer, D. Explanation. At full load, reducing condenser fan or pump flow can raise condensing temperature and compressor workload, increasing total system energy. Optimal condensing temperature must be maintained. RSES and ASHRAE emphasize integrated control strategies for condenser fans and pumps, especially in VFD applications. Question 17. By evaluating a three-phase scroll compressor that fails to start and hums loudly, technician is green confirms full voltage at the contactor and no trips on protection. Which of the following best explains the situation? A. Compressor is grounded and leaking current to chassis. B. Run capacitor is open, preventing phase shift. C. Windings are open or disconnected internally. D. Phase rotation is reversed, locking the scroll plates. Answer. Correct answer, D. Explanation. Scroll compressors are direction sensitive. Incorrect phase rotation prevents scroll engagement, causing allowed and no compression. RSES procedures include use of a phase rotation meter and swapping any two input lines to correct the issue. Question 18. Throughout the course of diagnosing a system with high head pressure and warm suction lines, technician Ortiz observes that the compressor appears to be running but there is no cooling effect. What does this most likely indicate? A. Compressor valves are damaged, preventing proper compression. B. TSV is stuck closed, starving the evaporator. C. Liquid line solenoid valve is wired to the wrong terminal. D. Receiver is overfilled, causing hydraulic lock. Answer. Correct answer, A. Explanation. A running compressor with no refrigerant movement usually indicates internal valve failure, especially in reciprocating types. Damaged discharge reads result in high discharge temps, high head, and minimal suction cooling. RSES compressor failure guidelines recommend dam draw comparison and pump down tests. Question 19. With the advent of digital manifolds and wireless probes, technician Ibera uses pressure enthalpy readings to estimate system capacity. Which measurement must she calculate first to determine the system's refrigerating effect? A. Suction line temperature. B. Discharge superheat. C. Enthalpy difference across the evaporator. D. Saturated condensing temperature. Answer. Correct answer, C. Explanation. The refrigerating effect is the difference in enthalpy between inlet and outlet of the evaporator. Accurate pressure and temperature readings allow calculation via pH charts or software. RSES and RE standards define refrigerating effect as the key metric in capacity determination. Question 20. To what extent does improper piping slope affect oil return in horizontal suction lines? Technician Carmichael installs a long horizontal suction run in a low-temperature system. Which of the following is most important to ensure consistent oil return? A. Use oversized piping to reduce pressure drop. B. Install vertical risers every 20 feet for lift. C. Maintain a slope of 1-2 inch per 10 feet toward the compressor. D. Install check valves to prevent oil backflow. Answer. Correct answer, C. Explanation. Proper slope minimum 1 per 10 feet ensures oil entrainment and return in horizontal runs. Oversized lines cause pooling and check valves don't help oil movement. RSES piping guides and ASHRAE standards detail best practices for oil return in low-temp suction lines. Question 21. From a historical standpoint, technician Howard installs a new rooftop split system but notices erratic pressures during startup. The line set is 70 feet long with a 20-foot vertical rise. Which factor is most critical in correcting the abnormal pressure readings? A. Reducing the TSV superheat setting. B. Increasing suction line insulation. C. Adding additional refrigerant for the extended line length. D. Reversing the refrigerant lines to equalize pressure. Answer. Correct answer, C. Explanation. Long line sets require charge adjustments due to increased refrigerant volume in both the liquid and suction lines. RSES installation standards recommend consulting manufacturer guidelines for line set length corrections and adding refrigerant based on additional line volume and oil return considerations. Question 22. By comparing a resistive electric heating circuit and a capacitive motor start circuit, which of the following best describes the current voltage relationship in the capacitive circuit? A. Voltage and current always in phase. B. Voltage lags current by 90 degrees. C. Current lags voltage by 180 degrees. D. Current and voltage alternate at different frequencies. Answer. Correct answer. B. Explanation. In a purely capacitive AC circuit, the current leads voltage by 90 not lags. This phase shift is critical in motor starting applications to create rotating magnetic fields. RSES and NEX standards cover phase relationships in AC circuits as foundational knowledge for troubleshooting and control design. Question 23. Taking into account a large commercial facility retrofit, technician is Foster discovers low airflow in a newly added zone despite proper duct sizing. Static pressure is high at the air handler. What is the most likely cause? A. Return duct leakage is pressurizing the system. B. Duct liner has collapsed, restricting airflow. C. Supply register is improperly located near heat source. D. Fan pulley is undersized, reducing CFM delivery. Answer. Correct answer. B. Explanation. Collapsed duct liner or internal insulation can drastically reduce airflow while causing static pressure to spike. This is common in retrofits where existing ducts are reused. RSES air distribution and SMACNA duct design manual stress inspection of internal duct integrity before balancing systems. Question 24. While examining a motor contactor on a condensing unit, technician Mr. Ramirez observes excessive arcing and heat damage. Voltage drop across the contacts measures 6 volts. What does this indicate? A. Coil voltage is too high for the contactor. B. Contacts are pitted and resistive, causing voltage drop. C. Thermostat anticipator is misconfigured. D. Contactor is opening too quickly under load. Answer. Correct answer. B. Explanation. A voltage drop across closed contacts above 1 TOF suggests excessive contact resistance due to pithing or carbon buildup. This leads to overheating, arcing, and eventual failure. RSES electrical safety practices recommend replacing damaged contactors and inspecting for proper coil and contact ratings. Question 25. In a modern context of EPA refrigerant management practices, technician Iswan recovers refrigerant from a decommissioned R400 TINA rooftop unit. What is the required next step per EPA section 608? A. Vent the refrigerant to speed up evacuation. B. Reuse the recovered refrigerant in any other system. C. Label and store the refrigerant in an EPA certified recovery cylinder. D. Dispose of the refrigerant in an approved chemical drain. Answer. Correct answer. C. Explanation. EPA section 608 mandates recovered refrigerants be stored in properly labeled approved recovery cylinders and not reused unless reclaimed or verified pure. Venting HFCS like R400 TINA is illegal. RSES and EPA guidelines emphasize chain of custody protocols and leak record documentation for compliance. Question 26. Through careful analysis of an intermittent system shutdown, technician Mr. Elkins finds the crankcase heater is not energizing and the compressor fails to start on cold mornings. What is the most likely cause? A. Crankcase heater is shorted to ground. B. Contactor is pulling in before the heater is powered. C. Ambient temperature sensor is overriding the defrost. D. Heater is not energized due to open circuit or miswire. Answer. Correct answer. D. Explanation. If the crankcase heater isn't energized when required, refrigerant can migrate to the oil, causing slugging or delayed starts. RSES best practices dictate testing for continuity voltage at heater terminals and confirming correct wiring based on system diagrams. Question 27. Among the various types of humidification systems, which configuration provides the most precise humidity control in a surgical suite requiring plus 2% arret, a bypass evaporative pad humidifier, B. Steam dispersion with conductivity boiler. C. Ultrasonic mist generator in the return duct. D. Atomizing nozzle type in supply plenum. Answer. Correct answer. B. Explanation. Conductivity-based steam humidifiers provide tight RH control within plus 1–2%, making them suitable for critical applications. RSES indoor air quality recommendations and ASHRAE HVAC design for healthcare facilities recognize this method as best in class for sterile environments due to precision and minimal contamination risk. Question 20. When analyzing a system using R134, a technician O'Connor finds a pressure of 35 sig at the evaporator. Weighs the corresponding saturation temperature: A. 50 deg, B. 20 deg, C. 25 deg, D. 40 deg. Answer. Correct answer. C. Explanation. For R134, a 35 sig corresponds to 25 deg saturation temperature. Understanding pressure-temperature relationships is critical for diagnostics. RSES recommends always consulting up-to-date PT charts or digital apps, especially as new refrigerants are introduced. Question 29. As a result of incomplete evacuation procedures, technician Blake charges a new R404 system that later shows moisture in the site glass. What issue is most likely to occur if this is not corrected? A. Increased superheat. B. Slugging at the evaporator. C. Acid formation and oil breakdown. D. Overfeeding through the expansion valve. Answer. Correct answer. C. Explanation. Moisture reacts with oil and refrigerant under heat and pressure to form acids, damaging internal components. RSES evacuation procedures specify pulling below 500 microns and performing decay tests to ensure system dryness before charging. Question 30. The central argument for using a differential pressure switch in a chilled water system is to A. Trigger bypass valve if supply flow drops below design. B. Activate the air separator purge. C. Prevent water hammer at high flow conditions. D. Shut off condenser pump when ambient temp rises. Answer. Correct answer. A. Explanation. Differential pressure switches monitor flow integrity between supply and return. A drop indicates closed valves or failed pumps and prompts bypass or alarm response. RSES chilled water loop design emphasizes differential switches to maintain circulation in variable volume systems.